All right, degrees and radians. So a degree, something you've seen in geometry for sure, is represented with that little kind of circle thing. That's our degree representation, and it's 1/360th of a complete revolution. Remember, the circle is 360 degrees. Each angle in a coordinate plane, so if we have coordinate plane meaning like x and y, each angle within that coordinate plane has two sides. It has the initial side, so that's the starting point, and the terminal side. Initial and terminal. When we're drawing angles, an angle in standard position is when its initial side is on the positive x-axis. So considering that visually, if the initial side is on the positive x-axis, meaning right here, we consider that to be standard position. When we are working counterclockwise, so going this way, counterclockwise will produce positive angles, whereas clockwise, so working the opposite direction, will produce negative angles. So our coordinate plane, we want to consider in the same way that we always have, really, with our x and y axes, quadrant 1 in the upper right, 2, 3, and 4, kind of rotating counterclockwise. So when we're thinking about angles, we want to kind of keep that in mind. And usually we'll be working with angles in standard position, so meaning that initial side is on the x-axis. So angles, as we're moving down, angles in standard position can be classified according to the quadrant in which their terminal side lies. Angles can be first, second, third, or fourth quadrant angles, or it can be quadrantal. An angle is quadrantal if both sides are on axes. So the measure of a quadrantal angle is always a multiple of 90 degrees. So quadrantal angles are when both sides are on axes. So like if the initial side was on the x and the terminal side, let's say, was on the y. So like we had a 90-degree angle there. So let's practice drawing these angles in standard position or sketching. So if we want to sketch an angle in standard position, we need to draw both the initial side, the terminal side, and then we draw this line to represent the direction of the angle. So we also want to here classify each angle by its quadrant. Unless it's quadrantal, just say it is. So here, so we have a 60-degree angle. So we're always starting in standard position. So our initial side will be on the positive x-axis. If it's a positive angle, remember we work counterclockwise. And really the kind of key thing here to remember is that going around, we work in 90-degree increments here. So 0 degrees to 90, 180, 270, and back to 360. So if we want an angle that's 60 degrees, that means it's got to be in our first quadrant. So 60 degrees would get us to something like there. 60 degrees, about 2/3 of the way from 0 to 90. And notice we use this curved arrow to represent what angle we're talking about. Because technically we could have another angle going in the opposite direction. It'd be an angle that's larger than 90 degrees. It'd be 300 degrees. But we want to make sure to use that curved line to represent which angle. And this is in quadrant 1, so I'll just say Q1. Okay. Next we have 270 degrees. So again, we start on that positive x-axis in our standard position. 270 degrees. go around to 270. So that's going to get 90, 180, 270. So it's going to finish on that y-axis. So with angles, you're probably used to more angles being less than 180 degrees, thinking about geometry with things with like triangles and things. In pre-calc, our angles can get quite large. They can actually get infinitely large. We could have an angle that's 1,000 degrees, for example. And we will talk about kind of how to represent those. And our last is a negative angle. So we have theta equals negative 45 degrees. So again, we're starting on that positive x-axis for our initial side. And since we have negative 45, that means we should go clockwise. So 45 degrees. So again, each axis tells us a distance of 90 degrees. So going this way would be negative 90, so halfway between would get us to negative 45. And that's quadrant 3. Sorry, we forgot to answer that last. Number 2, B, is quadrantal because it both starts and finishes on an axis. It's not technically in a quadrant, it's on the axis. Okay. All right. So that's how we draw or sketch our angles. The next thing I want to talk about are coterminal angles. So you can probably make a guess about what those mean based on the name. Coterminal are two angles that have the same terminal side. So if they're in the standard position, so having the same initial side, two angles are coterminal if their terminal sides are the same. So if we have the same starting and the same ending angle, we call those coterminal angles. They have the same angle measure. So we have an example here of two angles, so 120 degrees and negative 240 being coterminal. So this angle here, starting on our initial, going to 120 degrees there, is coterminal with negative 240 because they have the same initial and the same terminal sides. They start and end at the same place, so we call those coterminal angles. You can always find angles that are coterminal by adding or subtracting any multiple of 360, because 360 is a full revolution. So like even if we consider 120 degrees, if you subtract 360, you get that negative 240. And you could continue to subtract more. You could subtract another 360 to get negative 600, and that would give you another. And you could continue or add in the opposite direction as well. So that's what we'll do here. We'll practice coming up with those coterminal angles. So, coterminal angles. So, two angles, one positive, one negative, that are coterminal with the given angle. So, we have theta is 53 degrees. So to find coterminal angles, remember you add or subtract 360 degrees. So 53 plus 360 gets us to 413 degrees. 53 minus 360 gets us negative 307 degrees. So we have a positive and a negative coterminal angle. Okay, negative 120 now. So with this one, we can add 360 to get 240. So there would be a positive coterminal angle. And then we could also subtract 360 to get negative 480. And that would be negative. So just adding or subtracting those values. The other type of angle that we need to focus on here and consider would be reference angles. So reference angles are defined. So if theta is not quadrantal, meaning it doesn't start and end on our x and y axis, or x and or y axis, there's a unique acute angle. So remember, acute means less than 90 degrees, formed by the terminal side of theta and the positive or negative x-axis. When theta is in standard position, we call this unique angle the reference angle. And I think it'll make a little bit more sense as we consider this visually. Before we do that, it's important to note your reference angle whether theta is negative or positive, is always going to be positive. So we have some images, here, showing those reference angles. So the reference angle, again, it's that acute angle formed by your terminal side, so your ending side, and the x-axis, never the y. So if our angle here is A, the reference angle would happen to also be A. If our angle here, A, so this is our terminal side. The acute angle, so less than 90 degrees, or the closest x-axis would be my negative x-axis. So this would be my reference angle. Down here. So if we have A here, this is our terminal side. The reference angle is the angle between that terminal side and the x-axis. So this would be my reference angle. Over here, my reference angle would be here. So you're just looking at that terminal side and then the closer of the two sides of the x-axis. Okay, so let's do a couple of examples here. So here what we're going to do is we're going to find the measure of the reference angle. So we have theta is 115. So this is our angle. So the reference angle is the angle between our terminal side, so this side here, and the positive or negative x-axis, whichever is closer. So the positive x-axis is further, so we can focus on the negative. So this would be our reference angle, so I'll just write ref. And reference angle is represented by alpha. So alpha here. So if this angle here is 115 and all the way around is 180, then our reference angle would be 180 minus 115. So what's that? 65. Notice we are not using this angle here. Not between the y-axis, only the x for reference angles. All right, here we go. We've got another. So we have theta's 340. So again, that angle would be represented by going all the way around like that. So the reference angle is from the terminal side to the x-axis. So if this is 340 all the way around, to get back to the beginning, we'd need to go 360. So 360 minus 340 is 20. So our reference angle, alpha, would be 20 degrees. Okay. So just to recap, coterminal angles. So we kind of have two things. Coterminal angles, angles with the same initial and terminal sides. So difference of 360, positive or negative. Reference angles is that angle between the terminal side and the x-axis. Always less than 90 degrees, always positive.